Hello, and welcome to a project overview of the BinSight.ai mobile app. This cross-platform app was built as a senior capstone project by computer science undergraduates Blake Pugh, Daniel Lau, Kimberly Markley, and Micah Stalberg. In the face of an escalating climate crisis, finding more effective food waste disposal methods remains a pressing challenge in the field of sustainability research. To contribute valuable data to efforts in this field, the BinSight.ai team pioneers one approach that is aimed at expanding our understanding of food and organic waste at the household and consumer level. Our project supports a countertop smart compost bin equipped with sensors that capture images of food waste and many associated data points. These include bin internal temperature and humidity, CO2, the weight of composted food items, thermal imaging depth maps, and VOCs. As a part of this larger project, we created the mobile BinSight.ai app to provide a reliable and seamless connection between users and their smart compost bins during a field study planned for summer of 2024. At the beginning of development for this app, we identified 3 objectives. The first and most important was to implement a Wi-Fi connection with Bluetooth bridge to successfully connect the bin to its cloud database. The second objective was the creation of custom image annotation tools that enable users to outline and label food waste items in order to build a novel dataset. Finally, we wanted to create a dashboard with data visualizations and analytics to support food waste goals and to increase user engagement.
Looking more into the overarching architecture of the project, we can see a division between the app and the compost bin it interacts with. Users begin with setting up their bin. Here in the app ecosystem, we can see there is a Bluetooth bridge that is created where we write characteristics to the bin in order to deliver the Wi-Fi credentials. At that point, the bin can connect to and interact with the cloud ecosystem. Once connected, users can insert organic waste into the bin where sensors and a camera will capture the pre-detection data, which is sent to an API built using FastAPI, where the detection data is processed and stored. These detections are then available for viewing and, more importantly, annotating within the app. Users can enter their custom annotations of the image that is then stored in the local SQLite database and sent to the cloud database. Furthermore, upon opening the app, a query will be made to the cloud database and retrieve any detections made since the app was last opened, and save those to the local database, keeping the app up to date with the bin. With this architecture covered, let's dive into the research project's primary objectives.
One of the first objectives we tackled in this project was to implement a setup process that enabled users to connect their smart compost bins to Wi-Fi. This entailed sending the Wi-Fi network connection credentials like the SSID and password to the bin, which required a Bluetooth connection so the user's phone could interact and thus tell the smart compost bin that information. Due to the constraint placed upon us by the readily available Flutter libraries, we managed to accomplish this entire flow using our own custom-built Bluetooth and Wi-Fi implementation. Our next objective was to allow users to access photos taken of their composted items, outline them, and provide a label for machine learning algorithms to train on later down the line in this project. Some of the largest considerations involve the format of the outlines, whether to use bounding boxes or segmentation maps, and even the categorization of our labels, as well as finding an appropriate taxonomy that achieved our needs. Overall, our efforts on this project have ultimately led to the development of a cross-platform mobile app that accomplishes all of our core objectives we set for ourselves. We have also published the app to both the Android and Apple app stores in preparation for the field study that will take place during the summer of 2024.
So here's a demo of our application. First, I'm going to show you one of our first objectives, which was to connect the application to the smart compost bin. After approving the permissions for Bluetooth, the bin will appear in the scan and you can connect to it. Once this is done, the user will be prompted to select a Wi-Fi network nearby to the bin to be able to complete the process of connecting it to the internet. After typing in the credentials and verifying it is correct, we can send it to the compost bin verify the internet access, and grab all the things we need in order to run the app properly. Once setup is complete, the user will be taken to the home page where I can show you the second objective, which is annotations. In this list, we can see a list of all the previous detections from this bin, some of which have already been annotated as shown through this green shape compared to the rest of the white ones. To start an annotation, we would click on one of these tiles and press the Annotate button. There is also a useful tutorial of showing how to annotate. We can hide this. To annotate, it's pretty simple. We just follow the tutorial and outline the object here. In this case, this looks like some kind of fruit. To find this fruit, we press Select a Label, where we can search for the object. In this case, let's search for pumpkin. Once the label is selected, press Save to confirm the annotation, and it appears on the image to show that it has been done. We can also annotate a second object, and this one is an orange. Once all the annotations are complete, the user can press Save and Exit, and this will be saved in the cloud. It also appears in the UI as annotated on the individual page as well as in the list. Finally, as an additional bonus, the user can view different categories of annotations as well as see different trends of data over time.
We will now demonstrate how users will interact with their smart compost bins.
Please describe the item you have deposited.
Grapes.
At this point, the voice input has been captured, all the sensor readings have been taken, and an image has been taken of the food item that was placed in there. All of that data gets sent up to the cloud API and is processed and stored on the database, where the mobile app will then retrieve and display for the user to annotate.
On behalf of Soundbender Lab and the BinSite.ai team,
Thank you.